This massive ice stream is already in a phase of fast retreat, a collapse, when viewed on geological timescales, leading to widespread concern about exactly how much, or how fast, it may give up its ice to the ocean. A new study in Nature Geoscience led by marine geophysicist Alistair Graham at the University of South Florida's College of Marine Science adds cause for concern. For the first time, scientists mapped in high resolution a critical area of the seafloor in front of the glacier that gives them a window into how fast thwaites retreated and moved in the past. The team documented more than 160 parallel ridges that were created, like a footprint, as the glacier's leading edge retreated and bobbed up and down with the daily tides. It really blows my mind how beautiful the data are. Beauty aside, what's alarming is that the rate of thwaites retreat that scientists have documented more recently are small compared to the fastest rates of change in its past, said Graham. At some point in the last 200 years, over a duration of less than 6 months, the front of the glacier lost contact with a seabed ridge and retreated at a rate of more than 2.1 km per year, 1.3 miles per year, twice the rate documented using satellites between 2011 and 2019. Our results suggest that pulses of very rapid retreat have occurred at Thwaites Glacier in the last 2 centuries, and possibly as recently as the mid-20th century, Graham said. To collect the imagery and supporting geophysical data, the team, which included scientists from the United States, the United Kingdom and Sweden, launched a state-of-the-art orange robotic vehicle loaded with imaging sensors called RAN from the R.V. Nathaniel B. Palmer during an expedition in 2019. RAN, operated by scientists at the University of Gothenburg in Sweden, embarked on a 20-hour mission that was as risky as it was serendipitous, Graham said. It mapped an area of the seabed in front of the glacier about the size of Houston, and did so in extreme conditions during an unusual summer notable for its lack of sea ice. This was a pioneering study of the ocean floor, made possible by recent technological advancements in autonomous ocean mapping and a bold decision by the Wallenberg Foundation to invest into this research infrastructure, said Anna Wallen, a physical oceanographer from the University of Gothenburg. The images RAN collected give us vital insights into the processes happening at the critical junction between the glacier and the ocean today. It was truly a once-in-a-lifetime mission, said Graham, who said the team would like to sample the seabed sediments directly so they can more accurately tell. But the ice closed in on us pretty quickly and we had to leave before we could do that on this expedition, he said. While many questions remain, one thing's for sure. It used to be that scientists thought of the Antarctic ice sheets as sluggish and slow to respond, but that's simply not true, said Graham. Just a small kick to thwaites could lead to a big response, he said. According to the United Nations, roughly 40% of the human population lives within 60 miles of the coast. This study is part of a cross-disciplinary collective effort to understand the Thwaites Glacier system better, said Tom Fraser, Dean of the USF College of Marine Science, and just because it's out of sight, we can't have thwaites out of mind. This study is an important step forward in providing essential information to inform global planning efforts. The study was supported by the National Science Foundation and the UK Natural Environment Research Council through the International Thwaites Glacier Collaboration. The 2019 expedition was the first in a 5-year project dubbed Thwa, which stands for Thwaites Offshore Research, and also included team members from a sister project called the Thwaites-Amundsen Regional Survey and Network Integrating Atmosphere Ice Ocean Processes, or TARSAN. Video U2.be/est0rxf4 rock materials provided by University of South Florida. Original written by Kristen Kusek, Communications Director for USFCMS. Note: content may be edited for style and length. Faster in the past. New seafloor images of West Antarctic Ice Sheet upend understanding of Thwaites Glacier retreat. At times in its past, retreat of the massive Thwaites Glacier was even quicker than it is today, heightening concerns for its future. Science Daily. Faster in the past. New seafloor images of West Antarctic Ice Sheet upend understanding of Thwaites Glacier retreat. At times in its past, retreat of the massive Thwaites Glacier was even quicker than it is today, heightening concerns for its future. Faster in the past. New seafloor images of West Antarctic Ice Sheet upend understanding of Thwaites Glacier retreat. At times in its past, retreat of the massive Thwaites Glacier was even quicker than it is today, heightening concerns for its future. Science Daily. https://ift.tt, vocum znv, access September 5, 2022. Thanks for watching. Please subscribe my channel for more videos.